This is just a quick tutorial on making graphs, and the first thing I want you to notice is there are no trials in the data table. I basically took the trials out so it's already averaged for you just for the simplicity of making the graph. So on most data tables you'd have trials, but you don't normally graph the trials, you would just graph the averages. So how do we set up a graph? And this goes along with the handout on how to make data tables and graphs, and this is the section on graphs, just an example for you. So how do we make a graph? First thing is, in your data table, again, remember you have the independent and dependent variable, and you always put the independent variable on the x-axis of your graph. So we're going to fill in that variable. And then you're going to do the same thing for the y-axis. You're going to put the dependent variable on the y-axis. And that's just something you have to memorize. You need to always know that the independent variable goes on the x and the dependent on the y. And you'll notice I put in parentheses, not super neatly, but I put % in parentheses for average grade in science because that's the unit it was measured in. The x-axis is just a number, it's not using any units, so there's no units listed. Include a title, same thing with data tables, the two variables, and then if there's any extra detail you can add it. In this example there's not any additional real detail since it's just an example. Now you need a scale of numbers, so you want to look at your highest number in 8 and come up with a scale that will stretch across the x-axis, and you do the same thing for the y-axis. And once you have that, you're going to plot it. Okay, just like in math class, you have an x and a y value. You plot those, and then you draw what's called a best fit line. And the best fit line, or the line of best fit, doesn't necessarily touch every dot. You're sort of averaging the data points. So in this case it looks like more of a curved line rather than a straight line, so I average those with a smooth curved line for a best fit line. Okay, this comes from the handout called Time to Start Graphing, which is really an additional example for you to use on how to make a graph. Again, I left out the trials in the data table because usually we just graph the x and y value, which is the y value is usually an average. So let's get this going here for you. Again, you're going to want to take the time, the independent variable, and put it on the x-axis, the dependent variable on the y-axis, include units. The title would have the two variables, time versus temperature. And what's hard to read there, it says mystery liquid, time versus temperature of the mystery liquid. Now you got to come up with a scale. I'll pause it there just for a second. Notice on my scale I skipped a line every time. I went 1, 2, 3, 4, 5, 6, etc. That's because the highest number I have to graph is actually 7.5, or actually in theory 10, even though there's some missing data points there. And so I skipped a line to spread my scale out. You want your highest number to be past the halfway point on the graph paper. So I had to stretch it out. If I didn't skip a line, I would end up with a 10 about halfway on the x-axis. And you could fill in the missing numbers there. It's counting by halves, so it's a 0.5 and then 1 and then 1.5, etc. Now, on the y-axis, I purposely count wrong to start with. And I'm counting by 10, 20, 30, 40, 50, 60, 70, 80, but you'll notice that the biggest number I have to graph, the biggest number I have to graph is actually, see if I can get that back, about 85. I put a little line there, and that's not halfway up the graph. So I want to refigure that scale out, and the way I did that was skipping a line and counting by tens, or another way of saying that would be counting by fives. Notice I started both axes at 0. Each axis starts at a 0. Okay, and I didn't list it right, the blue one, but I probably should have. Then the data points, I just do the x, y values just like you would in math class. And it looks like it's a linear relationship to start out with. Okay, so I actually used a ruler to draw my best fit line, but I wouldn't want to keep it going straight. There's too much evidence that that data is sort of leveling out, so I used just my hand to draw a smooth curve line, and I extended it past the last data point. So that's the basics on making a graph, and hope that helps you out.